Imagine a perfectly sealed metal box sitting on a table. Inside it, an impossible physical event is actively taking place. The cat inside is simultaneously physically alive and dead. It occupies two mutually exclusive physical states at once. The moment you pry open the lid, you force reality to choose. Before that second, both outcomes exist. After it, only one survives. The implication was so disturbing that even Erwin Schrödinger, one of the physicists who uncovered the mathematics behind it, rejected the conclusion. Schrödinger used this scenario to highlight the logical outcome of how the microscopic building blocks of our universe operate. To understand the problem, we have to look much smaller than a cat. When physicists first studied atoms, they realized that particles like electrons do not behave like tiny solid spheres. They spread out, acting exactly like waves. This probability cloud represents a wave function. Unobserved, an electron explores all paths simultaneously, building a blurred distribution curve. But the exact moment it is measured, those possibilities vanish. The wave collapses into one sharp, solid location. That sudden transition from infinite potential to a singular reality is the central mystery of physics. No one knows exactly what possesses the power to trigger that collapse. What happens if we take that microscopic uncertainty and mechanically link it to a macroscopic object that we can actually see? This flowchart maps out the beginning of Schrödinger's Plaxi setup inside the box. It starts with a single, unstable radioactive atom. Over a set period of time, it has exactly a 50% chance of decaying. That atom is wired to a detector. If the atom decays, the detector triggers a hammer. The hammer smashes a vial of poison, and the poison decides the cat's fate. If the atom does not decay, nothing happens, and the cat lives. The math requires that before observation, the atom exists in both states. Because of the physical link, the detector must be both triggered and untriggered, and the poison both released and contained. Following that chain reaction to its end, the macroscopic cat itself is forced into a dual reality, completely alive and completely dead. The equations predict experimental outcomes for individual atoms with perfect precision, but when applied to an animal, they clash with our observation of the physical world. We do not see half-alive cats. Physicists searched for the exact physical boundary separating the microscopic from the macroscopic. They needed to find the threshold where reality is forced to choose. This animated model of a standard double-slit experiment shows particles passing unmeasured through two openings. They interact with themselves, creating a multi-banded wave interference pattern on the back screen. But if you place a physical detector at the slits to observe which path the particles take, that complex wave pattern vanishes completely. It is replaced by two distinct single-band impact strikes. This carries a deeply unsettling implication. Simply knowing the path the particle takes dictates whether it exists as a wave or a solid point. The logic falls apart when you remember that physical detectors lack consciousness. They are inert metal and wiring. They cannot know anything. They only physically interact, which suggests observation might be the wrong word entirely. If conscious observation isn't the trigger, the collapse must be driven by sheer physical interaction with an environment. When a delicate quantum system bumps into its surroundings, its multiple possibilities leak outward, tangling with the countless other particles it touches. This rapid washing out process, where the quantum possibilities fragment and fade, is known as decoherence. Decoherence unravels Schrödinger's original setup. The concept of a perfectly sealed box is an illusion. The cat is constantly radiating heat, displacing air molecules, and undergoing biological processes. These constant physical interactions continuously measure the system. The environment forces the large-scale system to instantly resolve into one physical outcome. Decoherence destroys the balance required for a dual state before a human ever opens the lid. While decoherence explains what we see, it leaves a lingering mathematical truth. The equations never actually eliminate the alternate state. They just hide it from view. The many worlds interpretation argues reality never collapses. Instead, a single timeline branches into two diverging paths. The act of measuring splits the observer into separate versions. each traveling forward on an isolated timeline. It sounds like science fiction, but it strictly obeys the quantum math. To date, no physical experiment has ever managed to disprove it. You are left with a choice. You must either accept that unobserved reality exists as an infinite series of mathematical ghosts, or accept that reality itself is constantly fracturing. Does looking at the world cause it to solidify into a single reality? Or are you simply riding one specific branch of a multiverse, entirely oblivious to the paths that carry on without you?